Hello. Sometimes when I do projects, I do them in a more complicated way than is really necessary, just for fun and to make things more interesting. And that's what I did with this project. It's about harvesting rainwater from the roof of my bungalow. There is no machining in this video, so you can switch off now if you're interested in machining. I have got 3 of these 200-litre green water butts. 2 of them are around the bungalow and another one is up by the garden shed. And these are fed in the ordinary way from the downpipe. So, during June and August this year, the UK experienced a prolonged period of dry weather, which culminated in a severe summer heatwave, record-breaking temperatures posing challenges for water resources. This graph shows 2022 up here, with exceptionally high temperatures and exceptionally low total rainfall. I live down here in the red area, extremely dry. My garden is on a 1-acre plot, so there's quite a lot of flowers to keep alive during this drought. So during this drought, I let the lawns look after themselves because I knew they'd just go brown, and as soon as it rained again, they'd green up. I watered the rest of the garden with a watering can, but after a few weeks I'd emptied all 3 water butts. That wasn't a problem because I could refill the water butts from the hose, but that lasted. I did that twice, but then they imposed a hosepipe ban, which meant that you couldn't water the garden with a hosepipe, but I think you could still water the garden with a watering can. Probably I could have still filled up the water butts with the hose as long as I just kept using the watering with the watering can. But I thought that that wasn't a very good idea if we needed to save water, so I just struggled on. And fortunately the drought ended more or less as I ran out of water. But I realised as a result of that I actually need more water storage than I've got. So I was going to get this 7,000-litre plastic container and put it up the hill where my garden shed is. But there was a problem with that because they said you must have a forklift truck to unload this from our lorry. I said, haven't you got a HIAB? A lorry with a HIAB? They said, no, we'll look into that. And they came back and said, oh, that'll cost you £500 extra. So obviously I wasn't going to do that. So I abandoned that idea. And I decided in the end to get 3 of these 1,000-litre plastic tanks, which are quite narrow and would fit round the bungalow satisfactorily. They are quite expensive. I'd have been better advised in terms of value for money to get these IBC containers in a metal cage, which are quite a bit cheaper. But on the other hand, they're the wrong shape to fit round the bungalow. So I went with 3 of these 1,000-litre tanks. And I kept the 3 200-litre water butts, so I ended up with 3,600 litres of storage, which is 6 times more than I had in the first place. So I put 2 of these 1,000-litre tanks around the back where I keep my dustbins. So this water butt is filled up from the guttering in the normal way. And inside we have a 24-volt submersible pump somewhere down there. Down there we have a 24-volt submersible pump, and on the side we have two float switches, of which you can see the top one here, which sense the level of the water. And the idea is that when the water gets up and activates the top float switch, then it turns the pump on and it continues pumping until it gets down to the bottom float switch. So we pump this much water in one go. My idea in using this pumping arrangement was that the water butt would act as a kind of filter, preventing most of the gunk that comes down from the roof actually getting into the main tanks. The pump is sitting on a brick, so it's above the base of the water butt, and I never pump down to the surface of the water, so any rubbish that either falls to the floor or floats on the surface doesn't get pumped into the tanks. So if I had a little rainfall to bring the water level above the top float switch, pump turns on and pumps the water into the tank. And there's a float valve in the tank which stops the pumping of water from the water butt into the tank when the tanks are full, until this float switch operates. Or until the water butt is emptied down to the bottom level switch. Of course, I originally raised this water butt up on blocks so that the watering can would fit underneath this tap. When I originally bought these water butts, they came with a free tap, somewhat like this, only I found that the water didn't come out very fast from it. So I replaced it with another one which has a slightly bigger outflow. Because the point is, when you're watering plants using a watering can, half the time you spend waiting for the watering can to fill up, so doing it fast is an advantage. So sitting at the bottom of the tank is a 24-volt submersible bilge pump. I think it's 1100 gallons per hour, and it comes up here. So the idea is that when we want to fill the watering can to water the plants, we press the green button and it produces a good flow and fills the watering can up quickly. The only problem is when we take our finger off the green button, it still continues to flow because the water level is up here and it's just siphoning out. So I have to stop it at the moment, like that. I'm working on a solution to that problem. Well, I wanted to use this bilge pump for a purpose. It says this is 28.5. It says the ID of this is 28.5. But it isn't. Neither of these is as stated, which is typical for everything in Britain. So I thought, oh, all right, I'll make a Delrin adapter which fits on here. So, being impatient, I overshot that diameter. All right, so I made another one where I didn't overshoot the diameter. That will fit on nicely. But then I overshot this ID. So I thought, all right, I'll make another one. And that's exactly right. But however, I didn't want it to be exactly right. I wanted it a bit tighter than that because it's got to be waterproof. I've got to be able to force it on. So I made 3 of these things, and none of them is right. And I'm buggered if I'm going to make another one tonight. So it's a good thing I've got plenty of this Delrin, isn't it? I've got a lot more Delrin than I've got patience, I can tell you. So I'm using an old electricity meter box to hold the electronics. And I started off in a very crude way with just having a transformer, a bridge rectifier, capacitor smoothing it to provide 24 volts DC. Of course, this is bad because it has no EMC filtering. But there's a more serious problem, and that is that this is a 200 VA transformer, which is perhaps more than I need, but what I hadn't realised was that if this transformer is completely unloaded, it still takes 20 VA all the time, and in fact it gets quite warm. So you're just dissipating electrical energy as heat all the time, even though you're not drawing any current. And I calculated that even on electricity prices last year, before the energy crisis, this is going to cost me £50 a year just having it on all the time without actually drawing any current. So I abandoned this idea and decided on a different arrangement. The gubbins that actually controls the pump is just that little relay there with a snubber network around it. So I got rid of the transformer and replaced it with batteries and all this stuff up here. Basically all this stuff is just a very complicated way of charging a 24 volt battery, but it also performs the important function of isolating the pumps and switches completely from the mains. I decided to use an Arduino to do the logic of the battery monitoring and charging. So what we got here is a 24 volt battery which goes through a changeover relay here, which can either connect the battery to the load, which is the pumps and the switches, or connect it to this off-the-shelf 24 volt battery charger. So when the battery is charging, it's not connected to the pumps and switches at all, and therefore the pumps and switches are not connected in any way to the mains. And when the battery is connected to the pumps and switches, then it is completely disconnected from the battery charger and from the mains. This other relay here just turns the mains on to this battery charger so that it's only powered up when we actually need it. So the Arduino monitors the battery voltage, and when it goes down to a certain point, it initiates a charging cycle. Whilst I was here with these things, I thought I would add 2 counters to count the number of times the batteries have been recharged and the number of times we've actually pumped the water into the water tanks, because that was easy to do. I've also provided this circuit with a solar cell that monitors the daylight, so that it doesn't initiate a battery charging operation except in the middle of the night. The only point of that is so in case you were actually using the pumps during the day, it would be irritating if it suddenly turned off because it wanted to do a charging cycle, which would take several hours, and then you wouldn't be able to use it during that period. So that's what all that is for. Much more complicated than I originally intended, but completely safe. So that's how it normally looks with two 12-volt batteries in series in the bottom there. And then I discovered during the almost tropical storms that we've been having recently that these meter boxes are not really waterproof at all. So I put that lead hat on it, and that seems to work. So despite first thinking I can do all this with one relay, I don't need to use an Arduino, I ended up with this rather more complicated circuit connected to the Arduino. Basically these are just FET switches that the Arduino can turn on or off to drive the relays and to drive the counters. And then there's a photocell connected to the A to D input of the Arduino so that it can measure the daylight level, and some voltage dividers so that the Arduino can measure the battery voltage. And it also actually monitors the battery current using this rather nice bespoke current monitoring op-amp TSC 2010, which has the property that although it's only powered from 3 volts, it can actually measure negative and positive voltages with respect to ground across this current sensing resistor. I'm not quite sure how it does it, but it certainly does work. And over here I have an off-the-shelf converter that will take up to 36 volts input and produces 5 volts out for the Arduino. That's the program in the Arduino. It's very simple, you can look at it if you want to. You may be thinking, why have this very complicated method of switching the battery charger in and out of circuit and controlling it with an Arduino when you've got an off-the-shelf commercial battery charger in there, and it has 3-stage control which will automatically switch to a float charge when the batteries are charged. So why not just connect the battery charger to the batteries all the time and let it sit there on float charge, which would probably actually be better for the health of the batteries. But there are 2 problems with that. Firstly, I don't know how much current this battery charger takes when it's on float charge, but it will certainly take some current from the mains all the time. So that would get back to the problem that I had in the first place, albeit not so seriously. But the more important point is that if the battery charger was permanently connected across the battery, then the only thing that's isolating these submerged 24-volt pumps and buttons from the mains would be this battery charger. And that's probably made in China. Are you going to risk your life on that for the next 5 years? And I thought, no, I'd rather have a more reliable way of isolating the working parts of this system from the mains, which is why I used that relay. Of course, one does not need to have this enormously complicated system. If we go round the side of my bungalow to the back, we'll find I've got a third 1,000-litre tank, and this one is filled from the guttering directly without the assistance of any float switches or pumps. I've still put a pump inside it so that I can get the water out because the outlet is too low, and I didn't want to put this whole tank way up in the air, which would look ridiculous. I painted this one same colour as the house, partly to make it blend in, and partly because I found in the hot summer months that these black tanks actually get quite hot, and just painting it this colour completely eliminated that problem.